Hello everyone, welcome to class 7 in our cybersecurity foundation series. So today we are going to look at a very interesting topic in our series, that is intrusion detection with Snort. Our learning objective is that by the end of this class, learners should understand what an IDS or IPS is and why it is critical in cybersecurity. Distinguish between host-based and network-based IDS/IPS. Understand the difference between signature-based and anomaly-based detection. Understand the architecture and operational stages of Snort. Install Snort and write simple detection rules. Interpret Snort logs and then understand alert output. So, okay, what is IDS and what's IPS? An intrusion detection system, IDS, is a security tool that monitors and analyzes system or network activities to detect signs of malicious behavior or policy violation. It works passively, meaning it does not stop attack, but alert administrators when something suspicious is detected. So, IDS is actually, the intrusion detection system that actually gives you an alert if something suspicious is coming in. Let's say maybe there is a lot of traffic on your network, there is a particular port that is trying to the attacker is trying to connect to. It can just give you a brief alert that, oh, this person from this IP is just trying to do this based on the rules maybe you have set. And then let's look into IPS as well. IPS is intrusion prevention system. So this one takes a little step further. So unlike IDS that only detects and does not do anything, it just detects it and maybe send it to your SIM if you have one and you've configured it to send it there. IPS does a better work of detecting it and blocking it or preventing this traffic as well in real time. What is host based versus network based? So we have HIDs and NIDs. Host-based is particularly looking at that system. The monitoring processes and monitoring activities is based on the endpoint, the system that is being, the IDS is being targeted to monitor. Why NIDS is monitoring the whole network, maybe the network interface, or maybe a mirrored port from a switch. You can actually monitor the traffic to see what is actually happening on the whole network. So network based is monitoring activities on individual system or host, analyzes log, system files, configuration and active processes, detects internal threat like unauthorized file change or privilege escalation. So when once an attacker goes into a site, he will try to change some files, permissions, and then try to escalate its privilege and try to maintain some persistency. So it is the duty of the host-based intrusion detection system to detect all these activities going on in the system. So we have some IDS or HIDS. Yeah, example of HIDS, they are OSEC, Wazoo with agents, the tripwire. Why network-based IDS or NIDS is monitoring the entire network traffic flowing through a router, switch, or firewall. So it examines the packets in real time to detect patterns or known attack signatures. So example of it is Snort, Suricata, or Zik. What are the features of host-based intrusion detection and network-based intrusion detection? So we have their location. Mostly host-based intrusion detection system is located on endpoints, like maybe the server, the client system, while the network-based intrusion detection system is running on a network or a gateway. The visibility, so it sees all the local OS activity, it sees all the things that's happening only on that particular system it's been assigned to monitor. But the network sees all the packets on the network level. So all the packets, the traffic that is going on maybe the network, the IDS have an idea of what is going on there. And if there is any malicious activities, it detects and then pull it up to maybe the SIM tool or just put an alert to you, or locked the activities to a log file. So use cases, it detects insider abuse, while the network-based does what? Detect external threats. Overhead, most CPU/RAM on the host, so you need a dedicated interface. So you assign a dedicated interface for the network intrusion detection system to actually monitor. So in practice, most organizations use both HIDS and NIDS for complete visibility. So, but we are going to focus on Snort on this tutorial, and that is Snort for intrusion detection system. So the signature-based versus anomaly-based detection. Signature-based detection uses a predefined attack patterns, rules, or signature to detect threats highly accurate for known attacks, cannot detect new and unknown traits, while anomaly-based detection uses what statistical model or baseline or behavior, flag anything that deviates from that behavior. Good for detecting new or 0-day attacks, may generate a false positive. So basically, when you are doing detection rules, the anomaly based may generate some false positive detection, which means that it will give an alert which are not true, and then it can even flood your system. And then once the alert that are true comes in, and it will be harder to detect. So it's best to use the signature based detection, as it is written here. Snort is a signature based NIDS, so relying on written rules to match malicious activities. So Snort overview and architecture. Snort is a powerful, lightweight, and widely used open source network intrusion detection system developed by Cisco. So it works with capturing packets and comparing them to a set of user-defined rules to detect suspicious or malicious activities. So it's not architecture, packet decoder, reprocessors, detection engine, login and alert, and then output plugins. So what is the duty of a packet decoder? The packet decoder does what? Captures the traffic from the network interface. So you're going to specify the interface. It can be ETH0. We have a lot of interface that people use in their network. You have to just specify the interface, and then the packet decoder will do its job to capture the to capture the network or the packet. So the preprocessor does what? Normalize this packet, reassembly the fragment, decode the protocol. So if it's going to wait for some packets to come in to complete a frame or a segment or anything, it is the duty of the preprocessor to do that, and then look into it, decode it, and look at the protocol, and allow the detection engine to do its work. So detection engine does what? Look at this packet. Does it match the predefined rules? If it matches it send it to login and alerting. So it generates an alert when the rules are triggered. So that is the duty of the login and alerting and detection. And the output plugin sends what? Alert to console. Either send it to console, or send it to syslog, or send it to a file maybe that you are specifying. Installation on Linux. So it's not work on both Linux distribution. On most Linux distribution. Below are steps for Ubuntu Debian system installation. So at first you update your repository with sudo apt update and then sudo apt upgrade. Then you install Snort by what? Sudo apt install Snort. As simple as that. Then during installation, you'll be prompted to enter what? Your network IP range. We talked about network IP range when we were doing introduction to networking in our week 2. So it should be conversant with IP address and the range as well. So you can see that these two 24 here, 24, that is 192.168.56.0/24 is going to have a system of about 254 hosts. Yeah, so this within this range of network, there should be a space to host about 254 systems. So for you to verify if Snort is being installed, just Snort dash version, or you can use Snort dash version, and then you see the version of the Snort that's in your system. So when you install Snort, there are a lot of things you need to configure. One of it is the main configuration files, which is in what? exe snort and snort.config. So if you use Vim, because basically I love using Vim to do my editing, you see the software there. Then the custom rule file. Then if you want to define your own personal rules, which we are going to using the custom rule file, we are going to comment out most of the community rules. Then you make use of the custom rule file so that we can see how Snort actually work in real time. So you just have to go to your exe snort rules/local.rules file, and then you see a place to put in your rule there. So this does not config to include your own rule file, and then include the rule part in of local.rules. So we are going to use Nano or Vim to open any editor of your choice. You can use it to open and edit most of those things. So writing Snort rule, it's very interesting. Though I'm going to show you a software that basically I use in writing Snort rule, that is Snoopy. Because sometimes it might be difficult for you to get to write all this rule offhand. So with the help of this software, Snoopy, you can just be clicking, and then to get you your rule ready to be used. So in the first syntax. You have the action protocol, source IP, destination IP, source IP, the source ports, destination IP, destination ports, and then the options. So, for example, we have the action can be alert, can be lock, it can be drop. If it is IPS, which you're not going to use it as IPS, that is intrusion prevention system, you are using it as an IDS. So basically, you'll be working on what locks and alerts. So alert, the protocol is TCP from any IP, from any port to any IP in our network. On port 80, message what HTTP traffic is being detected. Then this is SID is the unique ID of that particular row, then the ref, which is going to be 1. So we're just going to explain this. Alert is what the action Snort takes. It can be either be locked, as I said, alert, or what, or drop. TCP is a protocol to match. So when once it sees that this protocol matches that row, it will lock that that network traffic. So any and any means what? Source IP and the port. So from any IP and from any port. This is the direction of the network, which is maybe going into our network space. So the any here is trying to say any destination IP in our network on this port 80. Then the message is the message that will be shown on the alerts, which is what HTTP packet detected. Then the SSID is the unique signature ID. Then the REV is the revision number. So running Snort in alert mode. So if you want to run Snort in alert mode, which you alert it to the console, this is what we are going to use in our practical demo, so that you see what is happening in real time. You just have to sudo snort, then you give this option A, which is alert mode, and then you should alert it to the console. Then the Q is quiet mode. The C here is the path to the config file. The I is the interface that is going to monitor. So the interface can either be ETH0 or you just choose your correct interface, which can be what EMP0S3 or WLAN 0 or any interface at all. So understanding locks and alerts. By default, Snort locks are saved in where var locks not, and this is the part for most of the logs. You can see your auth log, you can see your boot logs, and most of it in var log. So that is where Snort also save most of its logs. So once you cut var log as Snort alert, you see most of the logs that is being logged into this file. Okay, so I'll use the console output, the A option, which is the alert mode. Then alerting is going to alert it to the console. So we are just going to go to our practical lab and try to put everything we have learned into action, and then try to see how we can use Snort to detect ICMP packets in real time. So let's meet in our Linux lab. Welcome to our practical demo on Snort as intrusion detection system. So if you have not updated your repository, sudo apt update, and your repository will be updated. Then sudo apt install, please. Apt install Snort. Okay, so you can see that Snort is already in a newest version. So it means I have Snort installed. I can check Snort version, Snort V, and then sudo Snort V. Okay, see the version I have here, 2.9.20. So once Snort is being installed on your system, you can configure it's on this folder, sudo let's say we'll go into exe folder and then Snort. So these are the Snort config file. Okay, so you can see we have the rules folder where you can define your rules. Snort config file. Most of your Snort configuration will go here. We have other process config file, the threshold, the classify config, and the rest. But because of this course, you're going to focus on the Snort config file and then the rules. So first, before we go into that, we are just going to try to check our IP address and then the subnet that it belongs to as well as our network range as well. So new window. Okay, so if config. So this is our network interface ENP0 is 3, and then we are in this subnet 255.255.255.0. So this is our network interface, and this is our IP address. So I'm just going to copy this. Just going to copy this 10.252.69, or we can get back to it later. Okay, so sudo vim. I'm going to use vim editor. Snort sudo vim snort.config. Okay, conf. So this is the config file. You can see VRT rule package snort.config. Most of the details about the Snort is being displayed, compatible with Snort version this, and then the rest. You're not going to look into that. Let's look at what captured our interest here. Okay, so the first thing is what? The first thing is the subnet that you're monitoring. So this is IP omnet. For the external network, it should be on any, but the omnet should be the IP address of your home network. So the IP address of my home network is actually, let's check it. That is 10.252.69.7. So I think I'll choose my I to insert that. 10.25252, I guess. Let me just confirm it again. 10.252.69.47. 10.252.69.69.47. Okay. Oh, so we are done with that. 10.252.69.47. I just want to confirm it again. 10. Okay. 10.252.69.47. So we are good to go. So external network should be any. If you have your DNS server, you can put the IP address. If you have your SNT server, you have the SQL server, Telnet, SSH, and this is the port that Snort can monitor. If you have other ports, you can also include it as well. So, so this is the path to the rule that Snort will use. So for the rule part, this is EXE Snort rules, which is where we're going to put in our rules. Then the sole rule part is given as well. The reproc rule part is given as well there. So blacklisting and whitelisting, these are rules maybe for blacklisting or whitelisting of IP or any network or IP. Let's focus on IP. So this is the rule that will do that job. Then these are just config file. Some of them are disabled. So with this hatch, they are disabled, and I disable the community rules as well, so that the rule we define, you can actually see it in action. So I disable most of the community rule. Okay, so I think that's what you need to know. Let's go down here to look at the community rule. So yeah, this is the part of the community rule that was included: the app detection rule, the attack response rule, the backdoor. If there is a backdoor attacks on the system, it will do well to detect it. The blacklist rule, the bonnets, CNC rule, the browser Firefox rule, and the browser WebKit rules, and the rest. A lot of community rules, but I've commented most of them out. The MySQL rule and the rest. So that's the list of the community rules that is being commented out. So I think that is what we need to do for now. And we are going to go out of here. I'm going to write and quit. Okay, so you can take a look at the rules. So you just cd into rules, and then you can look. You have the community rules, community NTP rules, community SNTP rules, and the rest. But this is not our interest. Interest is directed to this local.rule because that's where we write in our rules. So you can just go with sudo vim again, local.rules. Okay, so you can look at this. Then this where you add your rule. If I comment this out, this rule will not be active. Let me just insert that. And then if I put in hash here, this rule has been commented, but I'm going to use this particular rule, so I don't want to comment it out. So you can look at this rule. It's basically what we discussed in our Suricata section. This is the alert, which is the action. This is the protocol. Then any IP from any port coming into our home network into any IP and any port as well. Then you should message what ICMP ping detected, and then this is the ID, unique ID of this particular rule, which is 100001. Then this is the revision number as well. So we are just going to quit this. We're just going to work with this particular rule, and then we try to do a kind of ping request in our network and see if Snort will actually detect it. So let's get rid of this and start our Snorts. Okay, so we write and quit as well. Good and fine. So we have to start Snort. So sudo Snort. Then we give the alert option should be what? Console. Then to run in quiet mode. And then the path to the config file is exe snort, then snort.conf. Then the interface we are monitoring. You can go back here to look at our interface. Okay, so our interface is enp03. You can just copy that down here, paste it here. Wow, let's go and copy that again. We copy that. I think you can just type that. Just type that enp0 is 3. enp0 is 3. So enp what is happening? I think we got stuck somewhere. Wow. Okay. I think we just open another terminal. Let's go with a new window. Okay, so we are back. I'm just going to increase this. Snort, sudo snort, then you see we are running it in quiet mode, which is Q, and then alert mode also, we're alerting it to the console, where our config file is, which is exe snort.conf, and then the interface we are running this enp03. Let me just confirm that. Give me some seconds. Okay. EMP0 is 3. EMP0 is 3. Okay, I think we are good to go with that. So we just start. So Snort started. So all we need to do is just to, send a ping request from our Linux system. So I'm just going to go into my Linux system right away. And then, okay, I'll go into this. Oh, I was using this for my Wireshark tutorial. So I'll just clear my screen. Then try to ping, let's say 10.252.30. I guess that was it, dot 42.7. Okay, I think I'm missing something there. Let's just confirm our IP address from here. Okay, dot 69.47. So 69.47. 69, please. 69. Okay, so we have sent the ping packet. Okay, so you can see what is happening in our Snort N is detecting the packets. Try its best to detect the ping packet. So we have this ping detected, priority 0 ICMP from this is our IP address. It's coming in from this IP address. Let me reduce the screen for some reasons. Okay, so it's coming in from this IP address. 10.252.6947. So it's a ping request. So it's locking it in real time. I'm just going to stop that request from my Kali Linux. I can see it has also ended here. Okay, so I'll clear my screen right away. Then you can go for your logs. You want to see your log, you can go into not sudo, go into snort, no, exe, not exe, please, log. So you can see we have a lot of logs here. We have the abort logs, the auth log, which does our authentication log, the boot log one, boot log messages, and fail log, and the rest. So our focus is on snort logs. So we just go into snort, then you can see we have the alerts here. We have the snort fast one. We have the snort alert fast here. So we are just going to sudo less then snort.alert.fast. Okay, so you can see this is the ping packet that was detected by our snort when we were triggering that ping request. So it is being locked here. So that is it for that. We have come to the end of this class, and thank you for watching up to this moment, and I hope to see you in our other series. Until then, one love.